So I'm from RHE Global. We're a company that specialise in environmental health and community safety, consultancy, training and software solutions. So we're invited here today because some of the consultancy services that we've delivered to Safe Suffolk renters, we commonly deliver to local authorities, helping them undertake their enforcement. I'm one of those pesky environmental health officers. But we also deliver to government. So if you've heard of the HHSRS, we delivered the review to the Department of Levelling Up. We delivered the Welsh Housing Quality Standards to the Welsh Government. And we deliver training. So I deliver HHSRS practitioner training and identification training. And we produce the Noise Act for dealing with noise complaints and the Housing Act for carrying out housing inspections. So I won't dwell too much on definitions because I think a lot of this has been covered, but we're looking at visible mould growth, not forgetting that it can cause our buildings to deteriorate, and we're talking about humidity, and that's a lot of what I'm going to focus on in my presentation. Okay, so we've got different types of mould growth, as Joanne mentioned, condensation, rising damp, penetrating damp, not forgetting our traumatic damp. We could have leaks going on. But I'm going to focus a lot on condensation and managing moisture in our buildings. So why is it important? So as people have mentioned, we've got our health impacts. So there's a lot of specific definitions in terms of physical health. Okay, we're talking about respiratory conditions, increases in asthma, also allergic reactions. But we also need to remember, as Joanne mentioned, our mental health conditions. It's not nice to live in these places. It's not, it can produce anxiety, especially for parents as well, or anyone who's got dependents living with them. They're not just worrying about themselves, they're worrying on the impact that has on their family members that are living in that property. And as well as that, social isolation, not wanting to have people round. So lots of issues in the news, and I know that everybody's mentioned our Abhishek. I just want to focus on a couple of issues in particular within the coroner's report for that case, okay? So we know that Awab died directly from environmental exposure to mould, okay? The important thing we need to think about here is that their landlord, the family, had made several complaints about the housing conditions there, and the landlord failed to act. They blamed the family for causing the mould growth in that property. However, there wasn't adequate ventilation in that property. Okay, we know now that there was an extractor fan in the bathroom that didn't work properly. There was no window in that bathroom. There was no mechanical ventilation in the kitchen. And the window in the kitchen opened onto the communal walkway, so it wasn't directly to the external air. So despite the fact that we had inadequate ventilation in that property, the family were blamed for causing the mould. There were other complications, obviously, that the landlord delayed while legal action was taken, but we really need to reflect on the learning that we can have from the coroner's report and the points that were picked out by that case. So whether you're here as someone who investigates housing complaints, a landlord, a housing provider, we need to understand the root causes of what's causing our damp and mould growth in our building. You need to understand your own property, and we need to understand how moisture interacts with your property. Okay, so when we talk about moisture, we're talking about all forms of moisture. So we're also considering water vapour, okay? So that's moisture in the air, all right? In order to keep our buildings healthy, as well as controlling how moisture enters a building, we need to control how humid air leaves. And if we don't do that, it's going to lead to condensation, which actually rots our building as well. So do all buildings have the same needs? No, they don't. So different types of buildings interact differently with moisture. What we're looking at here is what we would call a traditional building on the left and a modern building on the right. When I talk about a traditional building, I'm generally talking about something that was pre-1919, solid walled property, built using traditional techniques and traditional materials. So in a traditional building, moisture is generally able to leave through the building structure. The natural materials used are what we call vapour permeable. So those buildings are designed to be vapour permeable. Okay? They're designed to have high levels of background ventilation, as well as moisture leaving through air bricks, chimneys, those drafty sash windows. We We've also got the movement of moisture through the vapour permeable walls because we use those bricks with earth and lime mortar, earth and lime being permeable in a way that cement isn't. In our modern houses, they're built very differently and also built maybe to suit our modern lifestyles a little bit more. So when we think about our older traditional buildings, we had a different style of living in those days. We had someone home all day with a fire burning. Bathing was mainly outside. It was in those, you know, in the tin bath. We had kind of constant heat and ventilation in those buildings, whereas now we have very often a heat and cool kind of pattern going on because we're all out at work and school and those sort of things. So our buildings are more repeatedly heated and cooled than was designed in those days. So we're kind of got different style of building, different style of living. So it's important that we know what our starting point is when we're thinking about how to manage that moisture. So thinking about vapour permeability, an example of vapour permeable design is our brick-built Victorian house, built to be built with lime mortar. And lime mortar is hygroscopic. That means that it absorbs moisture. Okay, so in this photo, it's not that clear when you blow it up, but you can see that the brick faces are kind of wearing away a little bit and the mortar's standing proud, okay? Usually, in a Victorian building, the most effective route for moisture to travel is through the lime mortar, okay? If that can't happen, it starts to concentrate into the bricks, okay? So sometimes, if we're seeing moisture issues like this, there's a material issue going on. So in this particular case, what happened is the building had been repointed and they'd used cement mortar rather than lime mortar. So what we had was the moisture moving through the bricks, okay? As well as that, the cement mortar doesn't bond as well to the lime mortar, so it can trap moisture within the bricks. So sometimes, if we're seeing moisture issues in a building, it can mean that we've not used the right materials. Sometimes we might need to bring in a specialist to help us diagnose what's going on. Do they know what they're talking about in terms of the differences in vapour permeable and non-vapour permeable materials? And this is not just externally, this can happen with plaster and paints as well, whether you're using the right material for the right property. Thinking about condensation then, so it's the process where water that is held in the air is deposited onto surfaces, okay? That happens when the temperature drops to or below dew point, okay? Dew point is the temperature when water droplets condense from the air. It varies, dependent on the environment, dependent on the air pressure, the humidity, the temperature. Basically, there's moisture in the air, in the house. When the internal air is warm, it holds more moisture. So as the internal air cools, it can hold less moisture. So the water in the air starts to condense on the coldest surfaces. If that surface isn't hygroscopic, so it doesn't absorb moisture, the moisture will stay on the surface and allow mould to grow. If it's hygroscopic, it will absorb the material, it'll absorb the moisture, and it can either kind of transport it through to the outside or hold it and release it when the humidity drops again. So a kind of passive regulation of internal humidity. So our causes of condensation then, high humidity. So we've got a lot of water vapour in the air. Low temperature, so as we've said, when the temperature drops, that's when the air can't hold the condensation anymore. So our lower temperatures, that's when it's going to chill and condense on the walls. And poor ventilation. We've heard a lot about ventilation. It is important. So humidity can be reduced by ventilation. If the air exchange isn't adequate, then our humidity accumulates indoors. If we've got humidity accumulating, then we're going to see more condensation. And when we're looking at the causes of condensation, we're looking at the type of dwelling, the insulation, the ventilation, the heating. Yes, the weather conditions, the location of the property, for example, if it's coastal, and the number of occupants and some of those occupancy issues. Two main reasons. So when we're thinking about those structural things, it's actually changes in building characteristics, disappearance of the styles of housing, different living styles, as we said, sealing up houses. So we take our old Victorian houses that were designed in a certain way and we change the way that we live in them. We seal them up, we make them more airtight because we want to be more comfortable in them. We want a higher level of thermal comfort within those houses. And our living arrangements, like we say, dwellings, we're leaving them unoccupied during the day a lot of the time, changing the heating system, and often we've got higher densities of occupation because there's a cost of living crisis. We've got families living together for longer, you know, adult children staying at home for longer, giving us bigger families living together. A little bit about explaining how your building works then. So the building envelope, when we talk about that, that's the structure of the building. That's the physical separation between the outside and the inside, okay? It's continuous. We're talking about the floors, the walls, the roof, okay? That's our building envelope. Within that, we've got the thermal envelope that we need to think about. So that envelops the insulated space within the house. It separates the indoor and outdoor temperatures. So the reason we've got a difference here at the top is because that's where our loft insulation is in this house. So that's the difference between the thermal envelope and the building envelope. And what we can get within that is thermal bridges. You might have heard them as thermal bridges, cold bridge, cold spot, okay? There are problem areas in the property. And it's a part of the thermal envelope that is less effective than the rest of the thermal envelope. So in an uninsulated building, it might just be a thinner area of the building. In an insulated building, it's an area where the insulation is thinner, okay? It's colder. So these areas perform less well than the rest of the structure, so they allow heat to transfer out at these points, okay? So they bridge or bypass the other areas. Because they're colder areas, they encourage moisture to condense on them. We talked about water vapour coming out onto those cold surfaces. Those are cold surfaces. So as those cold spots have moisture condense on them, it soaks into the fabric, they become colder still, so they attract more condensation, and it's a vicious cycle. And that's why you see issues like this, which is probably a fairly common sight where you see a lot of mould growth on the window reveal. So the reason that we get a lot of this is simply because they're a vulnerable part of the fabric, because they're thinner. There's less distance to the outside. The wall is this thick, the window reveal has a lesser distance to the outside. So it encourages condensation there because it's colder. But it also happens at other areas. So an uninsulated loft hatch, for example, could be a cold bridge where you're going to lose that temperature. So by understanding how moisture acts within a dwelling, it follows that, you know, we need to manage that moisture. We've talked about how water vapour condenses on surfaces at certain temperatures, so we need to control the temperature as well as ventilating. How do these impact damp and mould? So, okay, heating, we need heating to keep our internal air above dew point and ensure our surfaces are warm enough to discourage condensation. That, of course, links us to insulation. We need to keep that heat within the dwelling and tackle any cold spots. We need a combination of the two. They're not going to work in isolation. So if a house is poorly heated but with well-insulated walls, we're still going to have cold walls where moisture is going to condense. If it's well heated but it's poorly insulated, we're still going to have cold walls and that moisture is going to condense. And we need ventilation. We need to have that exchange. We need to be able to remove that humid air, okay? And that can be a combination of controlled and uncontrolled ventilation, so mechanical means as well as natural means. And we can use that to tackle our cold areas as well, our cold bridges. And as we mentioned earlier, in a traditional building, it's not just about the vapour permeability and the moisture. We might have actually removed some of our natural ventilation points. So if we've blocked up a chimney, if we've changed our windows and made them more airtight, then we need to add in ventilation to tackle that. If we've removed ventilation, we need to add ventilation. So what are we looking for then? We need efficient heating. We need it to be able to heat the space and keep our air temperature above dew point, okay? And we want it to be affordable so that it's not beyond a tenant's means to heat the space. And we want it to be understandable. So it may sound simple to us, but if you have a tenant that has never seen a storage heater before and doesn't know how they work, they are not going to use that system effectively because they don't know how to use that system and they don't understand that system. We need to explain it. And when we think about affordability, that links us directly to insulation as well. Are we losing our heat straight out of the house? Are they just pouring money and it's going straight through the walls, the roof? We've got most of our heat lost through the walls, 35%, and the roof, 25%. We want our 270 mil of loft insulation or equivalent. So making sure that if it's a flat roof, we've insulated the flat roof. Making sure that if it's a rooming roof, we've insulated the rooming roof. And although wall insulation is more costly, it can be very beneficial. And from what Gary said earlier, maybe it's worth talking to him and his team about some of the grants that are available in order to get that at a much reduced cost. And don't forget floors and draft proofing. That sees another 15% of loss, depending on the type of floor you've got, in the type of property you've got. That can actually make a huge difference. Thinking a little bit about EPCs then. So what does that tell us? It doesn't tell us everything, but it is the government's tool for assessing energy performance of buildings, and it can provide a good indicator of whether our dwelling is working well thermally. All right, so when we look at increasing the EPC score, we're directly improving the tenant's thermal comfort. So we're making it easier for them to heat the property. And if we make it easier and cheaper for them to heat the property, then we're keeping the air temperature above dew point and we're actually protecting the fabric of our property. We're reducing fuel costs. We're helping them be happier and keep the building warmer and be able to afford to heat the property, but we're also protecting our building as well, because if we reduce the amount of condensation, then we're protecting our own stock. And not forgetting the wider societal benefits. I can't remember which presentation earlier mentioned the cost to the NHS. You know, we're reducing carbon emissions, and if we protect our ageing housing stock, we're reducing the need to build new properties, and we're actually protecting our green spaces as well. So a reason I've included a little bit about that is when we're thinking about legislative requirements and we think about minimum energy efficiency standards, it helps to show how it's not just about temperature, it's actually about mould growth as well. If we're going up in the EPC bands, we're improving the temperature, we're reducing our risk of mould growth. So what do we do in terms of resolution then? So if we've got complaints, I think the first thing to remember, and when we think back to what we talked about, what went wrong with our Bishak and the Rochdale case, firstly, we need to respond sensitively. We've got to bear in mind that those occupants that we're dealing with that have a problem, we talked about how damp and mould can impact their mental health. So you could be dealing with someone who's depressed, who's anxious, who's feeling isolated. And on top of all those problems, if you don't respond sensitively, then it's just aggravating what's going on for them. And keep them informed of what it is that you're doing, because talking to them is another way to kind of keep that communication channel open, but also it's going to make them feel better. It's going to make them feel like you're being proactive. Assess how urgent it is. And when we assess how urgent it is, take on board how important it feels to them as well. Keep accurate records. Joanne talked about making sure you take photos. That's really important. Don't forget we need to tackle the underlying cause, and we also need to tackle what is happening as a result of the underlying cause. And if you have contractors in to do remedial works, make sure you inspect afterwards, because it's not necessarily, they've not necessarily done what they've said they're going to do in the way that they've said they're going to do it. So what should you do during your inspection? So whether it's routine or whether it's responsive, make sure you inspect inspect externally and internally and make sure you match up what's happening inside and outside. Someone talked about a leaking gutter. And, you know, some of those things, it's just a question of marrying up what's happening. Don't forget that you can have multiple causes of damp and mould in the same area. So, you know, in your living room, you could have a penetrating damp issue on one side and a condensation issue, you know, on another wall. It's not necessarily just one cause. If you're taking any kind of damp readings, look out for things like what height of the wall the damp readings change. Look for a sharp drop-off from wet wall to dry wall that suggests that there's, you know, a particular pattern of problem pointing you to a penetrating damp issue. If you're doing temperature readings, actually measure the surface temperature as well as the air temperature to help you think about what the dew point is, what's going on, how much condensation are you going to be getting on those surfaces. Think about using hygrometers. Your humidity levels ideally need to be in between 40 and 60, your temperature between 18 and 21. That's going to minimise the risk of condensation. So think about doing those kind of things while you're there as well. If you have anything visual that you can use, that can be really helpful to open those conversations with your tenant. So thinking about prevention after inspection, we're trying to keep the humidity down. As we've discussed, we want to limit mould growth by making sure as little water vapour as possible condenses on the surfaces. And no surprises, it's about ventilating, insulating and heating and generating less water as a last resort as well. It is a measure in there, but we need to be very careful about the way we talk to people about that. We can't tell people you shouldn't be showering every day. But we can tell people, make sure you put the extractor fan on when you're showering and make sure that you shut the bathroom door so that condensation isn't circulating throughout the dwelling. And using language that isn't blaming and isn't shaming them, because we're already dealing with someone potentially with mental health issues. They're feeling isolated, they're feeling depressed. And if you come in and tell them that they're living wrong, that's just going to cause more aggravation between the two of you and it's not going to resolve the issue. So it's about thinking about the language and thinking about how you deal with people and remembering that they've got a right to breathe in the property, they've got a right to bathe, they've got a right to cook. So it's about making sure that everything else is in place. Thinking about those cold spots that we talked about, in terms of prevention, if you are having insulation fitted, external wall insulation does present slightly less risk of having cold bridges simply because it's much easier to install a very consistent, even layer. But talk to your installer about how they are planning to ensure that you don't have cold bridges within it. And little things like on this photo, you can just see on the insulation fittings there. So they're little polystyrene plugs in the middle. They sit over the screw heads. They make sure that the screws don't form a cold bridge. Talk to your contractor about what they're doing. Make sure that they've got the knowledge that you feel they need because you don't want to spend huge amounts of money on external wall insulation just to find that every screw head is a cold bridge and you've got a problem. So make sure that they know what they're doing. If you're addressing an existing issue, something like the window reveals where we've got our cold bridge there, you can just insulate the window reveals. Just improve that area, make it less of a cold surface. Okay. Just a little bit about guidance. Numerous pieces of guidance. I think a lot of them have been covered, so I won't dwell on them, other than to say they're really useful. They will talk about full dwelling solutions. Talking about vapour permeability that we mentioned in terms of our traditional Victorian property. This guidance in particular acknowledges that previous editions did get it wrong a little bit and advised that vapour barriers were installed on the warm side of insulation. This edition acknowledges that a vapour barrier might not be the best move because we need to continue to allow moisture to move through a dwelling that's designed to be vapour permeable. So we are kind of learning as we go in terms of what's best for these dwellings. Thinking back to what we said about that British standard on the last slide in terms of a different approach for vapour permeable dwellings, that's the same in terms of the building regs part F and L. Okay, so in terms of energy efficiency improvements and ventilation, there is a slightly different requirement. So if a building is vapour permeable, designed to be built in that way, then improvements are only needed to the point where it won't cause deterioration of the fabric. So it doesn't mean don't do anything. It means you don't necessarily need to meet the same standard as a modern dwelling. You need to treat it in a different way. In terms of compliance with legal requirement, there's a number of pieces of legislation. Joanne's been through those, so I won't dwell on them. I just want to mention the government guidance that was published at the back end of last year. And it specifically addressed that point that I have discussed in terms of the lifestyle issue. And because it was based on some of the information that came out from the coroner's report after Awa Bishak's death. Okay, and one of the things that they say is that residents shouldn't be blamed for the presence of mould in their homes. It shouldn't be pinned on lifestyle choices, and that, as I said, cooking a meal, having a hot shower and putting clothes out to dry aren't discretionary activities. They are part and parcel of living in a dwelling. The home's a home, it's not an ornament. So we need to identify and address the underlying issues. We need to make sure that our heating's adequate, that our insulation's adequate and that our ventilation's adequate before we start pinning it on behaviour. So a little bit then on the future of guidance and regulation. It's just worth mentioning the proposed changes to the HHSRS following the review that was undertaken last year. One of the changes we were asked to implement was the introduction of baseline indicators, because a lot of people talk about the HHSRS being quite vague and not really being understandable for landlords or an accessible system. So the baseline indicators are designed to make it a little bit more accessible, a little bit easier to understand what it is an environmental health officer is looking for when they inspect your property. So these have been very generalised at the top, and they are more specific in this. But heating and insulation, heating that's controllable and can heat the dwelling to a reasonable cost, sufficiently insulated to retain the heat that's generated. We don't want to be just losing all that heat. And ventilation should have openable windows of adequate size. Bathrooms and kitchens must have mechanical extraction, which should be well maintained in good repair and working order. And every element of the property should be weathertight and watertight. Rooms should be free from excess levels of observable damp and mould growth, and there should be space or facilities to dry clothes. And that's what the baseline indicators will look like in the new HHSRS, so they will be very specific. That's one of the baseline indicators. It mentions that surface shouldn't exceed 5% damp and mould growth. I've put a few useful resources on there. So none of them are actually ours. They're just things that I think are quite helpful for landlords and anyone interested in learning a bit more about managing moisture in a dwelling. Okay. We also do a training course. There's a link on there for anyone interested. It's based on what I've just delivered, but much more comprehensive. Thank you.